All right, so this video is for the first part of section R4. We'll be factoring. I broke this lesson into two parts. So this first page will be, I'm kind of calling this R4.1. There is no designation in our book. It just means the first part of R4. Okay, and so if you look at the bottom of this page, you can see in the bottom corner, it gives you the homework, and so you will just look for the homework problems at the end of section R4. There is no R4.1. It's just my way of designating that this is the first part. The next part will be designated as R4.2. Okay, so let's factor. The first type of factoring that we want to do is just called the GCF, taking out the greatest common factor. So you have a polynomial, in this case more specifically a binomial, and you want to factor. And it's taking out, well, let's look at this example up here, I guess, before we go to the examples. So we have a trinomial, and we want to see, is there something common in all three terms? And we're going to factor that out. So sure enough, x is in all of them, and we can't take out an x cubed or an x squared because the highest it is in this term, the x is, the highest exponent is in this term is a 1. So that's what we're limited to. We can't take out an x squared because we could take an x squared out of these two terms, but not this one. All right, so an x we can take out. And then if we look at the y's, we have a y squared, we have a y, we have a y squared. So we can't take out a y squared. Because of this y to the 1, that's the most we can take out. So we're taking out an x, y. Notice there's no common factor among the coefficients either, so we're not allowed to take a 2 out or anything like that. Okay. You can sometimes take other things out. If you took a 2 out, then there would have to be a 1/2 in front, and we generally don't do that. It's possible that you could, in some strange cases we will see things like that. But generally, this coefficient is a 1, a 2, and a 4, and the greatest common factor among those is just 1. And so we would take a 1 x, y as the common factor out of that. Okay, so let's look at example A. What's common? Well, we have a 3. And we have an x squared and an x, so the common factor is going to be 3x, and we're going to factor that out. This is the reverse of sort of distribution, right? So when we take a 3x out of 3x squared, we're left with an x. When we take a 3x out of, you can't just say x, that's a common mistake. It's like, oh, we took it out, it's not there anymore. We still need a 1, sort of almost as a placeholder. If I took and distributed that back in, I'm certainly not going to start with a monomial. That would not give me a binomial that we started with. So you can check your answers to these by distributing that 3x back in, and you better get what you started with. All right. You might pause the video and try these other 3 by yourself and see what happens. See if you can get your answer. All right. So what's common here? A 4 and an x. This term doesn't have a y, so I can't take a y out. So we're taking a 4x out. That leaves y and then minus 2. And again, you can check by distributing the 4x back in, and you better get what you started with. All right, and then this one. The common factor here seems to be a 5, first of all, and then an a, and then a b squared. Okay, and what's left when we take that out? We get 2ab minus, and then we took the variables out and we took a 5, so that leaves us with just a 3. All right, and then this last one. Yeah, now this last one, you're going to take an x out, right? So x, and then you get y minus 2. Now sometimes, I'm going to probably none of these 4 examples you would need to do this, or there would be even a reason to do it. But sometimes you might want to take a negative out. So you could have negative x. I'm taking a negative 1 as the coefficient out. And so that's going to flip the signs of these things. Now, you really wouldn't want to do that here, but you could, and it would be negative y and plus 2. right? So sometimes we might want to take a negative out with what the GCF, and it flips the signs. And again, I could distribute this back in, and I should get the original binomial that I had. Okay, so that's factoring out GCFs, the greatest common factors. All right, let's look at what if we had a 3 terms or a trinomial. We have special trinomials called perfect square trinomials because the trinomial, when we factor it, ends up having a difference of a binomial that is squared. So we call it a perfect square trinomial because it gives us a perfect square, a binomial that is squared. So that's why we call it a perfect square trinomial. So we saw this in the last lesson, but we went this way, right? Instead of factoring, we were simplifying. So when you have a binomial squared, remember it's the first term squared, the last term squared, and twice the product of the 2 terms. So we have already gone, in reverse, but now we're going, in the opposite direction. So when we have a perfect square term and a perfect square term, and the center term is twice the product of the square roots of these. So square root of this is A, square root of this is B. So this center term is twice the product of the square roots of those first and last terms of that trinomial. That means this is a perfect square trinomial and can be written like this. Now you could factor this by unfoiling it and getting A plus B quantity times quantity A plus B. But we don't want to leave our answer as 2 binomials when they're identical. We want to write it as A plus B, one of them, squared. Okay? And then this other one is very similar, except the sign is negative here, which means we're just going to have a negative in the binomial that's squared. Okay? And we'll practice some of these in a second. All right, general trinomials. So that's just meaning we're going to take this and we're going to think about doing foiling in reverse. And we'll practice some of these as well. So you're not really foiling. What you're doing is you're doing the reverse of foiling. So that means the first 2 terms have to give me x squared. So I know they're going to be x and x. And then the last term has to, the last 2 terms have to multiply together to give me 2. So I know there's going to be a 2 and a 1 because there's no other way to get a 2 other than 2 times 1. All right. This sign tells me that the 2 binomials are going to have the same sign, either both negative or both positive. So negative 2 times negative 1 would be a positive 2. Positive 2 plus times a positive 1. A negative 2 times a negative 1 will give me a positive 2, and a positive 2 times a positive 1 will give me a positive 2. So I know that these signs are going to be the same because of this plus sign. And then this is positive, so that tells me, okay, they're positive. All right. So in the case, simple case, when the trinomial has a leading coefficient of 1, it's pretty easy. The first 2 terms have to be this, the product of the first 2 terms is this term, x squared. So it's going to be x and x. And the last 2 have to be the product of the last two terms in the binomials have to have a product of 2. And the sum of those, because they're the same, it's either the sum or the difference. In this case, the signs are the same. So the sum of these 2 terms must be the middle term. All right, so as a kind of a check. Again, we'll talk through more of those as we do some examples. And then grouping is when we have 4, usually 4, but 4 or more, and we look for common factor. There is no common factor among everything, but there's a common factor in the first 2, and there's a common factor in the second 2. And so we take an R out of the first 2, and we take an S out of the next 2, and then the remaining binomials in parentheses have to be identical at this point. If they're identical, then we can think about taking that binomial out. So factoring this parentheses out of each of these terms. So we think of this whole thing as a term and this whole thing of a term. And we factor that out in front, A plus B, and then what's left is the R plus S. All right, again, it'll make a little more sense when we go through some examples. All right, let's try this first one. All right, so first of all, we got to we got to figure out what kind of factoring is it that we're going to do. So we always, so it's 3 terms, so you might say, oh, is it a perfect square trinomial or maybe a general trinomial? But what you want to do first, always in factoring, is look for a greatest common factor. And so you notice there's a 3 in here. That's a greatest common factor. So factor that out. So 3, using GCF method, we have x squared plus 5x plus 6. All right. Now, we have a 3 out in front. We have a trinomial. It's not a perfect square trinomial because this is not a perfect square. So we would treat it as a general trinomial. Now, in some middle schools, some teachers have taught you to just use sort of this grouping method. Take this and break it into 2 terms, sometimes referred to as an AC method. But it's almost always faster to use what I would call trial by error. All right, so especially since this leading coefficient is 1. All right, so the first 2 terms, we're thinking about FOIL, but we're going in reverse. The first 2 terms, the first 2 terms have to be x squared. All right, well, they have to be x and x. Now, also, this trinomial may not be factorable, right? Maybe the only thing that this trinomial to start with is factorable. Maybe it's only GCF. And the resulting trinomial, after we took out the GCF, it may not be factorable, but we should try to see. All right, 2 factors that two numbers that multiply together give me 6, and whose sum is 5. Because this is a plus, right? This in front of the 6 is a plus. I know these 2 signs have to be the same. This plus sign tells me, oh, they're both plus. All right, and so we want 2 numbers that multiply together give me 6 and have a sum of 5. So it could be 6 and 1, but that doesn't add up to 5. That adds up to 7. So I know it's going to have to be 3 and 2, or 2 and 2 and 3, 3 and 2. All right, and so you check that, make sure the outer is 3x, the inner is 2x. That has a sum of 5x. This is clearly 6. The product, the last, and the first is x squared. So this works. All right, next one. So try factoring that. Again, we're going to use sort of trial and error method. The first 2 terms have to be x and x. Again, I would stop the video, you do these on your own before you listen to me go through them. See how you're good at it. This tells me the signs are different. One's going to be positive, one's going to be negative. So I'm going to wait and hold off till the end. All right, they have to multiply together to give me 24. And because the signs are different, their difference is going to be 5. So that sounds like 8 and 3, which has a difference of 5. Now, which sign goes where? Right? The bigger product of the outer and the inner has to be positive. All right, so this is going to have to be a plus. So we get plus 8x and a minus 3x when we do the outer and inner. And that would give me 5x. All right, try the next one. First thing I'm going to do there is factor out the common factor of y squared, and that gives me y squared minus 6y plus 9. All right, now try to factor this trinomial. Maybe that's it, right? Maybe taking out the GCF is all we can do, but try to factor that. And this looks like a perfect square trinomial, right? This is a perfect square. 9's a perfect square. This is twice the product of the square roots. The square roots of these would be, product of the square roots of these would be 3y. This is twice it. All right, so don't forget about your y squared out in front. And so this will be y minus, because it's negative, minus 3 quantity squared. All right, this is 4 terms. So think about what we're going to do there. This is going to be by grouping. So take something out of the first 2, that's a squared. Out of the first 2, that leaves me a minus 3. And we're going to take something out of this, plus there, and then take out a 4, and that gives me a minus 3. At this point, the parentheses have to be the same if it's factorable. If they're not the same, you either made a mistake or it's not factorable. And so now I'm going to take that and that out, the parentheses out in front, factor it out of this term and out of this big term. So that is a minus 3 times the quantity of a squared plus 4. And that's all we can do with that one, okay? I'm just thinking if this were a negative in here, this would be a squared minus 4. That's a difference of squares, and we would want to factor that, okay? And we're going to see that down here, special cases. All right, let's look at D. Again, pause the video and try these on your own, and then come back and see. Now, let's see. I'm going to do this by trial and error. All right. So we have 3a squared. Now, there's a couple things this could be. It could be 3a and 2a, or it could be 6a and a. For this one, I'm going to try 3a first and 2a. This is why this is referred to as trial by error. You're going to see if it's factorable using this. Notice there's no GCF, right? In the original problem, there's a 6, there's a 1, and there's a 12. No GCFs there. So I'm going to start with try 3a and 2a. If that doesn't work, I'll go back and try 6a and a. And now I want to try to factor 12. So 12 could be 4 and 3, or 6 and 2, that kind of thing. Now, let me just say one little thing that middle school teachers tend to not teach you. There was no GCF in the original problem. There will not be any GCFs in this binomial or this binomial. So that means the number I put next to this cannot be even. It can't be a 4. It can't be a 6, because then there'd be a GCF in this binomial. And that's impossible if there's no GCF in the original. If there's no GCF here, there won't be any GCFs in these, right? So like if we hadn't factored out the 3 up here, and we tried to just use normal trinomial factoring, we would have GCFs in the binomials because there's GCFs in the original. Here, there's no GCF, so this cuts down what I have to try, right? So, I'm taking quite a long time here with this problem to discuss it with you, but let's say the factors we're going to use are 4 and 3. Well, I know I can't put a 4 here, and I can't put a 3 here, so I might try 4 and 3. All right, the signs are different. Let's see. The outer is 9x. The inner is 8x. That's a difference of 1, which is exactly what we want. We just have to get the signs right. Okay? So I want the outer one. I want the bigger product to be positive because the result has to be positive a. So I want the 9a to be positive. So this 3 is positive. The 4 is negative. Generally, we think about, I want the bigger of these two, but it's not. It's the bigger of the products. So 3a and 3, that's got to be positive because that's 9a. And then 4 and 2a, that's 8a. I want that to be negative. So that's why the signs are the way they are. So, I did a lot of explanation, but this is pretty quick because I know I couldn't put a 3 here, and I couldn't put a 4 here. I also can't put 6 and 2 in because a 2 would be no good with this, right? Because I'm looking for factors of 12. So I wouldn't ever put a 2 here, right? 2 and 6. Can't put a 6 here because that would have a common factor with the 3. So it really limits the things you have to try because you just cannot have a common factor in either of the binomials if there are no common factors in the original trinomial. All right, next one, E. All right, here we have, let's see, this is a perfect square. This is a perfect square. Is this a perfect square trinomial? So what's the square root of this? 2m. Square root of this is 5. 2m and 5 is 10. This is twice. So this is definitely a perfect square trinomial. And it's simple as taking the square root of this plus the square root of this and then squaring it. Okay, so that's much faster than trying to treat that as a general trinomial. Okay, next thing. Now, let me erase some of this because it's hard to see. This is a 4y squared and a 16. Now, okay, that sounds like it might be a perfect square trinomial. These are perfect squares. However, the center term is not twice the product of these. I know because this would have to be even, right? And it's not even. So 65 this is not a perfect square trinomial. So what we're going to do is we're going to just try to factor this. So maybe the first thing we would do is try 2y and 2y, because that would give us 4y squared. However, remember, there's no common factors up here, right? 65 does not have a common, that's 5 and 13. That doesn't have any factors with the other ones. All three have to have the same factors to have a GCF. So that means there's no way it could be 2y and 2y, because when I break up 16, however I break that up with factors, one of them is always even, right? I could do 16 and 1, I could do 8 and 2, I could do 4 and 4. In both cases, I can't put even numbers next to the 2. So that tells me I know it can't be 2y and 2y. Otherwise, I would have common factors. So the only other 4y squared, the only other way it could be is 4y and then just y. All right. So, and again, I can't do 4 and 4 because then I have a common factor here. I can't have 8 and 2. I'd always have a common factor with the 4. So if this is going to work, it's got to be the 16 over here and a 1 here. Now, maybe this doesn't work, and maybe it's not factorable. But if it's factorable, it would have to be this, because we can't have any common factors in our binomials. All right, the signs are the same because of this plus, and this negative tells me it's got to be negative and negative. All right, so let's see if this works. So again, the first works. The last two work, give us 16. Let's try the outer. The outer is negative 64y. The inner is negative 1y. So that indeed is negative 65y. So that is correct. Okay? And again, that whole idea of common, no common factors in the binomial factorings really helps. Okay, let's try the next one. Is there a GCF in all of these? Well, there's not, right? This is made up of 3's. There's no 3 in the 8. So really, there's no common factors in all 4 of those. We would take a GCF out if we could. So it's 4 terms, so probably we're going to use some grouping. What's common in the first 2? That looks like what? 3x, y. All right, and that leaves us what? 4 y squared minus what? A 3. We took out 1x, so there's an x, 3x. All right, and then what are we going to factor out of these two? Let's do a 2 and x squared. All right, and that's going to leave us with a negative 4 y plus, we took out a 2x squared, that's going to be 3y, 3x. All right, now here's a problem, because these two are not the same, right? So either it's not factorable or I made a mistake. Now, I purposely made the mistake so you could see this, right? This is a common mistake that people make, is when you take out this 2x squared, it's kind of like what we're talking about up here. Sometimes you want to take a negative out as well, and this is one of those times. And so we have to have this binomial and this binomial the same exactly. And so we don't want to take out just a 2x squared. We want to take out a negative 2x squared. And so that makes this positive 4. If we distribute it back in, we get a negative. We distribute this back in, this has got to be a negative, so that when we distributed this back in, we get the positive 6x cubed. Okay? All right, so now the binomials are the same. All right, so you always should stop after you've factored those two things out of the first two and something else out of the last two, and make sure that the parentheses are the same. All right, so now we factor those out in front, those parentheses. So we have 4y squared minus 3x times what was left behind after we took the parentheses out. That is 3xy minus 2x squared. Okay. All right, now let's look at sort of some special cases for 2 terms. So we have difference of 2 squares. So if we are asked to factor the difference of 2 perfect squares, then it results, and we saw it in reverse, this is conjugates, right? It results in two conjugates. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Doesn't matter which one comes first, plus or minus, but I just do a plus b times the quantity a minus b. Okay, so that's a difference of squares. You've seen that one. I'm going to guess that most of you have not seen these other two, sums of cubes and differences of cubes. All right, now notice there's sum and difference of cubes are both factorable. Well, factorable, but the sum of squares is not. You cannot factor sum of squares. So if I said a squared plus b squared, how would I factor that? And the answer is you can't. All right, so we saw that up here, this one, right? This is a sum of squares. We were done. Couldn't do anything more with that one. Okay? All right, so the sums and differences of cubes. It's really the same formula. You just got to memorize it. So if I have two different cubes and they're being added. So the first thing I do is I take the cube root of the first term, the cube root of the second term, and then I take that first term and square it. The last term is the second thing squared, b squared. The center term is simply the product of the two. We'll worry about the signs in a second, the plus and the minus and the plus in a second. But the actual formula is a, the square root, the cube root of the first, b, cube root of the second, and then a squared, this is the b squared, and it's the product of a, b. Not up here where we saw perfect squares, it's twice the product. That's not the case here. It's just the product. So don't put a 2 in there. It's AB. A common mistake I see. And then for the difference, it's the same. A, B, A squared. The B squared's out here, and the AB in the middle. And then we use a little acronym called SOAP to remember the signs. So the first sign between the binomials is the same S, the same as we started with. The next one is always the opposite of what we started with. The last one is always positive. So it tells you what the three signs are. The same as what you started with, plus, this one was plus, this one's plus, this one was minus, this one was minus. The next one is the opposite. And then the last one, the sign that we need in that trinomial is always positive. So if you memorize it kind of like that, then really they're the same. You can think of it as if this was a minus, then this is a minus, this is a plus, this is always a plus, right? So you can kind of look at it that way. All right, so there's not two formulas to memorize, but really only one. All right, let's look then at factoring this down here, A. All right, so now we've got all kinds of things to worry about. So what kind of factoring is this? This is 4 terms. First, look for a GCF among all 4. Does not appear to be any. So now we'll use grouping. So we take an a squared out of the first. That leaves us with a minus 3. And then what are we going to take out of the second? We want a plus sign there. We want to take out a 4. We're factoring out a positive 4. And so that is a minus 3. The parentheses are the same. And so now we say a squared, I always like to put what I'm factoring out first. So I'm taking out the a minus 3 and then a squared plus 4. Now, it doesn't really matter which set of parentheses comes first, but that's just kind of how I always do it. All right, next one. Again, you should probably pause this video and try these on your own, seeing if you can get them, and then watch the video to make sure. All right, there appears to be a GCF here of a 3. So that's x squared plus 7x plus 8. And then, maybe that's all, but we should try to see if it factors more. And so this will be x and x, and then a product of 8 whose sum, the two products that multiply to 8, whose sum is 7. So that could be 4 and 2, but that product is not 7, it's 6. We could do 8 and 1, but that product is 9, not 7. So this is not factorable. I mean, it was factorable through a GCF, but that trinomial is not further factorable. All right, next one. Okay, so the coefficients have a factor of a 3 that could come out, and then I also see a y. So 3y can come out of that. That leaves us with c squared minus 16x squared. And now, maybe it wasn't obvious up here, but now we can see we have a difference of perfect squares. So don't forget, that's a common mistake. You concentrate on this and you forget that there's something out in front of that. This is c plus 4x and c minus 4x. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Remember, those are going to be conjugates. All right, let's try this one. Common factor here of 8, let's take that out. Makes it much easier to work on if you factor that out. 8a cubed minus 8y cubed. All right, so we took an 8 out. This one's a little tricky because 8 and 64 are both perfect cubes. So if you forget about the GCF, you will factor that, but you won't have it fully factored. You'll have common factors in there, and so you won't get full credit. So make sure that the best thing to always do is to factor those out first. All right, and so we have an 8, and now we have difference of cubes. So I'm going to have a binomial and a trinomial. It's negative, so I know it's going to be the same, opposite, always positive. And now I can just say, okay, this is the cube root of that, so it's a. Cube root of this, 2y. And then I take each of these and I square them. A squared, 4y squared, and simply the product of these two goes here. So 2ay. Okay? Next one. This one's a little bit trickier. I'm going to think of this as x squared cubed plus y squared cubed. And so now I have a sum of two cubes. It's just that my cubes, the things that I'm cubing, are themselves squares. But it still works the same way. All right, so I'm going to have a binomial and a trinomial. It's plus, so it's plus. It's the same. It's opposite. It's always positive. All right, so think about what's the cube root of this. So that's just x squared. What's the cube root of this whole term? Y squared. All right, now look at this and say, okay, what is this squared? X to the fourth. What's this squared? Y to the fourth. The center term, didn't really leave myself a whole lot of space there. The center term is simply the product of the two. So x squared, y squared. Okay? All right, let's go further on this one then. So this is, there's no GCF. 9, and that's 10, and 2, and 5, and 4. Those do not have common factors. So I just have to do trial and error. All right, so 9x squared. I'm going to try 3x and 3x. It could be 9x and x, but I'm going to try the 3's first. If I can't find something that's common, I can't get that to work, then I'll go back and I will try the 9x and x. All right, 20. All right, so notice if I do 20 and 1, then I'm going to have a really, think about what the center term is. It's kind of big, but it's not as big as if 20. That means one of these is getting multiplied by 3. That's 60. That's 20 is just going to be too big. So unless this center term is really big, I'm not going to try the biggest numbers. I'm going to try smaller numbers. So 10 and 2. Yeah, I'm going to try 5 and 4. let's see if that works. So we've taken care of the outer, right? The first two give me 9x squared, the product. The last two give me 20. Now I got to check the outer. So the outer is 15x, and the inner is 12x. The signs are the same because of this plus, and they're both positive, so I can put those in. So that gives me 27x. So that's it. 3x plus 4 and 3x plus 5. Okay? All right, let's look at G. There's no common factors in that one. So this is a perfect cube and this is a perfect cube. So we're going to have a binomial and a trinomial. The sign is plus, so it's the same. It's the opposite, and it's always positive. Sorry, I'm not giving myself a whole lot of room for these, but all right. So the cube root of the first, 2x. Cube root of the second, 3y. All right, now take this first term and square it. It goes here, 4x squared. The last term is this one squared, 9y squared, and the product of the two. Not twice the product, but the product. So 6xy. All right, next one. Now this one's a little tricky. Notice there's a negative in front. I'm going to suggest to you all the rules and everything that all the kind of the ways of factoring these and trial and error and stuff. It always has a positive. So I'm going to always suggest that when you have a negative leading coefficient with factoring, you take it out. So factor out a -1. That leaves us 6y plus 11y minus 10. All right, and now let's do that by trial and error and see if we can find something. 6y squared. I lost my squared there. All right, so 6y squared. I'm going to say 3y and 2y. Now, maybe it's wrong. Maybe it's 6y and y. But let's try this and see if it works. If it doesn't, then we'll try the other ones. All right, 10. It's not going to be 10 and 1. I think that's too much. It's going to be too big. The signs are different, so it's a little hard to tell. If it's 10, if it's 5 and 2, I can't put the 5 and 2. It had to be 2 and 5. That's 15. 15 minus 4. Oh, that's 11, so that seems to work. All right, so 2 and 5. Again, you can't have a 2 here because then there would be a common factor. So if it's 2 and 5, it would have to be the 5 with the 2 and the 2 with the 3, and that seems to work. The signs are different. I want the bigger number to be positive, so that means 3 times 5. That's got to be the positive 15, and negative 4y. That gives us negative 11. Oh, no, wait a minute. No, positive. Sorry, I'm losing track of which one I'm doing. I took a -1 out, so it's positive now. We want it to be positive. So the 5 and the 3 multiplied together would be positive 15 and negative 4. Okay. Just don't don't forget this out in front. I wrote it as -1. I mean, I suppose we could just put -2 out in front, but -1 is okay too. All right, next one. All right, so these are both perfect squares, right? 16 is perfect square, 81 is perfect square, a squared is perfect square. So this is simply difference of 2. So this will be 4a plus 9 and 4a minus 9. Okay. All right, so that's the first part of the notes. Often in homework, I will say 1 to 5a, that means all, and then 15 to 12 to 58e, that means even, right? I don't generally put an O for odd because that's confusing. If I said like 13 to 57 O, that would be weird, right? I mean, because it would look like 13 to 570. So I don't use abbreviations for odds generally, but I will use an E for even and an A for all. All right, so this homework is due next class. and it's in the book. So make sure you go to the end of section R4. Remember, there's no R4.1 in our book. That just means, it's my notation to mean the first part of R4. So go look at R4 and find the homework at the end of that section.